First thing we're going to talk about is the battering retaining system. One of the key content which I'm going to present is the sheet piling system. The sheet piles interlocked with each other to form a continuous barrier. Here we can see two types of the sheet piling system. One is the cantilever sheet piling, another is the anchored one. For main component for sheet piling products, it is common to see the hot rolled types, including U types and Z types. The difference is that for U piles is most commonly known piles, and it is of less base requirement because as you can see, it's a U pile compared to this Z pile. The distance between these two parts can be very short. But for the Z piles, they got high moment of inertia due to this shape and connection. It does take more space, but they got high bending moment resistance and is highly modulus, which can be cost effective. We can see these corner sections. They can be customized depending on the different profile and shape of the sides. Other components we can see including the concrete coping, which can be seen from this picture at the top of the sheet piling to prevent water seepage, and guide frames, which is very important at the beginning of the construction to provide accuracy of driving position. Here we can see two sets of steel horizontally located on either side of the steel piles. Here is the hydraulic bracing system. It is used as an internal support bracing, and there's no need for on-site welding for this system. While in Australia, the vibratory and vibration-free method can be adopted. In this picture, we can find this plant called silent piling. It is for the pushing down of the piles, which can benefit the site location on the high-density CBD area. Here is an example of the Jewel Hotel in Gold Coast. As we can see from the picture, it's a combination of different retaining system, which is sheet piling system and a short wall system. Another thing is there's steel bracing adopted in this area. Also, we can see sand anchors adopted in this area. Another key content I'll be covering today is the second pilings and the continuous pilings. This system often forms a part of permanent structure. So here I want to point out for the lower strength or for the primary piles, it is important to have enough strength to have low permeability and low early strength gained to facilitate the cutoff of the male piles. And sometimes the primary piles will be covered with the permanent lining. See the construction process, which is the 4 passes construction process. The first pass and second pass is for the primary piles to cast in. In the third pass, we'll be adding the secondary pile. If the secondary pile will be reinforced, we have to lower the reinforced cage. Here we can see a case study in Adelaide. Second piling retaining structure has been adopted in this site because it is a 5-level basement retaining wall, which is of heavy duty, and most importantly, it's closely adjacent to the heritage structure. The site has a type movement limitation because it's in the CBD area of the Adelaide. Another reason for adopting such a system is because of the complex soil conditions. This site has a high strength sandstone levels, so it's not for the sheet piling to drive through. And there's saturated sand and weak rock levels as well. The key content I want to explain is the anchorage system. Here we can see some examples. It can for the main application if the anchors will be temporarily existed. They will be distressed after gaining sufficient support. The typical configuration of an anchoring system includes a anchor head, a free length, and a bond length. Here are some pictures which showing the detail of the different configurations, either be temporary anchors or permanent anchors. Here I want to talk about the waders. There are 2 spaced horizontal steel channels, and their webs are back to back. There will be separators to keep the distance, and there will be plates and bolts. 2 construction process for the anchors and for the soil nails. The difference is that the soil nails have more of a horizontal holes, and it's typically a top-down process. In this case, we can find some angled bearing plates. They are for the settlement of the tie-down rods. For shot craning system used in Australia, they follow the American Concrete Institution conventions to spray the concrete or mortar using hose to project to the receiving surface at a high velocity. The advantage is that there's no formwork, so the cost can be reduced. It is suitable for the vast kind of substrata, including any shape of the surface. You can find some main applications, including the ground excavation, the custom rock simulations, the infrastructure, and retaining structures. In the case study, we can see they work from the down to top, and they spray the concrete to the mesh or called reinforcement. Some of them they're screening and floating the surface. So here comes the dewatering system. Two ways has been used to control the groundwater table, which is exclusion and remove of groundwater. This is hydraulic rim ditch pumping, which is one of the surface pumping system. At the bottom of the slide is a deep well system. It's part of the pre-drainage system, which includes well point, deep well, and horizontal drains. Let's have a look at the material and components. For the riser pipes and discharge pipes, we can see some flexible swing connectors connect the header pipes and the riser pipe. In this picture, we can see this is a well point surface pump. So the pump will be connected to the suction header pipe to extract the water from the header pipes. Here are some generators. This one is a three-phased generator, and this one is a silence skip-mounted one. The distribution board is also part of electrical control system. Here are some examples of the sedimental tank or the filtration system. The silt topper is for the confined site. These discharge pipes will connect to the sewer, discharge the water complying with the local code. This is an example of a staged well point system. Well points and vertical risers are first to be installed. There will be vacuum lines connect them together to the vacuum pump. The negative pressure will use to draw waters into the well point. The water goes through the vacuum manifold, vacuum line, and vacuum pump, then discharged. So the effective depth of the system is 5 to 6 meters, which means for the deeper excavation, multiple stages are needed. In this case, a combination of perimeter spare system and the deep well system has been adopted. These are the risers pipes for the deep well, and these are the spares for the perimeter system. We can also find the treatment tank and the filtration unit at the boundary of this site. Here is a closer look of the filtration unit mounted on the treatment tank. In the next section, we are going to talk about the dewatering management plan. The purpose of this plan includes addressing environmental issues, complying with legislative requirements, and it's actually a part of development application. In some states, they're also being used as assessment for water reuse, address some issues with the proposed reuse method. Here we can see an example of the DMP in Gold Coast. Another document we have to talk about is the pre-post dilapidation service. It is also called the condition of property. It is needed prior to the construction and may require after the construction. So basically, it's a neutral legal document. For the property owner or the tenants, it is a proof of the cause of damage on the property by construction activities. But for the builders and developers, it's a proof of the damage existed before the undertaking of the work. So the authorized parties for this report is the licensed building inspector, and they better be insured. The next thing I'll be talking about is the basement foundation system. One of the key contents is the piled raft foundation. It's a combination type of a foundation. The piles are used for the settlement mainly, and the raft element is for the ultimate loading capacity. The advantage is that they can reduce the piles strategically, very flexible because of the design of the piles, and the rafts can be very customized to different locations and settlements. But it's not for the soft clay around the area near the surface of the raft because there's no support for the raft. And it is not for the long-term consolidated settlement soil and soil subject to expensive. In my report, there's a piled raft foundation system as an example has been examined in Gold Coast, Australia. Here I want to show another case, a high-rise building called Macedon in Germany. The building sits on the Frankfurt clay. Initial different settlement has been shown on this picture case. The 3 to 6 meters thick raft and 65 board piles. Piles has been arranged in the 3 concentric circles. Actions between pile and pile, the pile and the raft, and the soil has been shown on this picture. The section of this building and the plan of the piles. See the raft here, the basement and the piles. Piles are of the different lengths and the different diameters.